Hey, so welcome back, and this is another daily code problem. So today it's called spiral matrix, and it's a medium level problem. So it's like a two-dimensional array traversal problem where you're given a matrix here, and you want to navigate it in a spiral kind of path. And so all that you want to return is like the actual path in which you traverse this matrix. So you just keep track of, the value at every single like cell that you travel in that particular order. And then you just finish once you can't kind of keep spiraling anymore without repeating a cell that you already visited. Okay? And so to do this, all that you got to do is basically keep track of 4 different variables. The starting column, s_c is what I use, the ending column, and then the starting row, which is like kind of this row right here, and then the ending row. And then other than that, you just need the kind of response variable or array that you want to output at the end. So let's go ahead and implement this. So what you do is you just define your result, and then you just want to return this at the end. And then let's go ahead and define our 4 different kind of flags or variables that we're using to keep track of those 4 different dimensions. And that will be the starting column, the ending column, the starting row, and then the ending row. And this will just be equal to 0, then the length of the matrix at 0 to get the number of columns, since this the number of columns and number of rows might not match. And then we also need the starting row and then the number of rows. Okay, and so from here, I think we also want to minus these by 1, just so we don't go out of bounds. And we want to keep evaluating this while our starting column doesn't overlap with our ending column, and our starting row doesn't jump over our ending row. Great. Okay, and so let's go ahead and start going from left to right, which is like the first path that we take. And so to do that, we just say, okay, let's go through every column in the range from our starting column to our ending column plus 1, since it's non-inclusive in Python. And then we want to add to our result this path that we're traversing. And so we just say at this particular index, so the current row is the starting row, since we are just traversing the topmost row here, and then we just want to iterate through every index that we're going through in this for loop. Okay, and so after this, because we just navigated through this entire topmost row, we want to decrement, or actually increment, sorry, our starting row, because we just visited it. Okay, and so now we want to go from top to bottom, right? And we want to do it from the rightmost column here, from top to bottom. And so to do that, we just say, okay, let's go through every row in this particular range from our starting row to our ending row, plus 1, since it's non-inclusive in Python. And then we want to append this path that we're taking, which is from the current row that we're at on the rightmost column, so the end column. Great, and so after this, then all that we want to do is something similar where we just traversed this entire rightmost column. So let's decrement our rightmost column, which is the end column minus 1 to bring it inwards. Okay, and so because we just evaluated these, we do actually need like an if condition to make sure that we're still within these bounds. Okay, so I think I can just do this here, and we'll want to do this twice since we're going to travel 2 other paths here. And so we want to do something similar where we want to say, okay, now we want to go from right to left on the bottommost column. So for every column in this particular range, from the end column to the starting column, -1, since it's non-inclusive, and we want to be going backwards, so we just decrement by 1 each time. And so once again, let's add this path to our result, which is the current row that we're at, which is the end row, and the current column that we're traveling through. And so because we just traveled the bottommost row, let's decrement it by 1 so it moves upwards. And so then we just say the ending row minus equals 1. Fantastic. And then finally, we want to go from the leftmost column from bottom to the top. And so then we say, okay, for every row in this particular range, from the end row to the starting row, -1, and then we want to decrement it, so we subtract 1 each time. So then we want to maintain this path once again, and grab it from our matrix here, and we traverse through every row, and then the column is the leftmost column, so the starting column. Okay, and then you just want to say, okay, let's take this column and we want to increment it by 1, since we're moving this leftmost column inwards. Okay, and so let's just see if this runs, see if there's any bugs. Looks good. And that's the solution. So for space complexity, it would be O of m by n, since this result will basically be all of the variables that is in this matrix. And so like a 3 by 3 will have 9 values, and so this matrix naturally has 9 values in it. Okay, and then for time complexity, same thing here, because we're just iterating through every single element once. It also will have a time complexity of O of m by n. Just to clarify, if you can't, just because it's kind of hard to hear that, O of m by n, where m is the number of like rows and n is the number of columns. Okay, so yeah, I hope that helped, and good luck with the rest of your algorithms. Thanks for watching.